Hi everyone, my name is Mark and I'm here with the Shell Stream program which is powered by NIHERST, and today we'll be looking at pressure in a fluid. Now we looked at pressure over a surface area already, and we know we can calculate pressure over a surface area using the equation P equals F over A. Pressure for a fluid is a bit different, however, because pressure for a fluid increases as depth increases. So the further down you go, the higher the pressure would be. Let's think about this scenario. Imagine you are in a pool filled with water, but you are floating on top of that water. The pressure on your body from that water would be zero because you are floating on top of the water. Now imagine you went to the bottom of the same pool. The pool is still filled with water, but you are at the bottom of the pool now. The water would now be exerting a pressure on your body since you are lower down or below the surface of that water. And that's how pressure works. The deeper you go, the stronger or the higher the pressure would be. So as depth increases, so does pressure increase. This is how we have the formula P equals rho GH, where P is the pressure you're trying to calculate, rho is the density of the fluid we are observing, G is the acceleration due to gravity, and H is the height or depth of the object which is submerged in the fluid. The same is for pressure with gases as well. Right now, the air around me is actually exerting a pressure on my body, but it's not significant enough to cause me any harm, and also my body is actually exerting an outward force on the atmosphere around me. So it kind of balances each other out. We only notice a change in atmospheric pressure when you're probably in an airplane or below the surface of water. Okay? Alright guys, so it's experiment time. You know, I like to do experiments and I like you all to try the experiments at home. So let's do a pressure experiment to see if pressure really does increase as depth increases. The first thing I'll need is a bottle. Right, next, I'll need a container to put the bottle in. Then I'll need some tape. You could use either masking tape or scotch tape, any tape you have available. Tape. Alright, so what we have to do, you all are going to make 3 holes in the bottle. So the holes would be one on top of the other. Okay, so let's say you have an imaginary line here. Try to make the holes line up as much as possible. So I'll make my 3 holes. So I made my 3 holes in my bottle. So I have 1, 2, and 3. Right? Remember, if you're making holes at home in a plastic bottle and you're using an ice pick, you could probably get some help from an adult because it can be dangerous. Okay, so try to get some help. So now that I have my holes in the bottle, what I'm going to do, I'm going to take the tape and tape over the holes in one long piece of tape. Okay, so you're not using 3 short pieces of tape, you're using one long piece of tape, and we're trying to cover the holes properly with the tape. Alright, so I covered the 3 holes with the tape, so the bottle is basically airtight once again. Now I'm going to fill the bottle with water. So try to do this over your container because I did it before and I wet the entire table. Okay, so that should be enough. Nice, so the bottle is ready. The final step now to see if this really works, I'm going to remove the tape. You're pulling off the tape in one straight pull, okay? And we'll see the water flowing out of the bottle. So let's see what happens. So as we can see, well, water is not coming out from this top hole because probably the pressure is too low, so it's flowing down inside here. But you can clearly see that this hole and this hole, the water is flowing further out from the bottom hole as opposed to this one. And that is because, as we said, pressure does increase as depth increases. So this hole is further down along the bottle, So the pressure here would be greater than the pressure here. And obviously, the pressure here would be the lowest. Okay guys? So you can clearly see how pressure works with a fluid. So try this experiment at home guys. Also, I forgot to mention, you're trying to make the 3 holes the same size. I did do that, but this hole, the water just wasn't coming out because the pressure was too low. Okay? So try the experiment at home. I'll see you all in the next video. Bye.
Hey guys, thank you so much for viewing and thank you for joining the Shell Stream program powered by NIHERST. We have made all these courses available on the Ministry of Education's website, and you could find that at learn.moe.gov.tt. So head on across there and get those courses. You don't want to miss out. Also, please, we ask you to subscribe to our YouTube channel. Go hit that subscribe button, click the like button, click the notification button so you could be updated with more educational and informative materials such as this one. And lastly, follow us on our social media platforms. That's Facebook, Twitter, and Instagram. Be part of the community and let's do this thing together, and we'll see you next time.